Hi, and welcome to our introductory video on how to use the SESAmpacity tool for minimum conductor size calculations. In this video, we will create a realistic test case to calculate the minimum conductor size for an underground cable which should withstand a fault consisting of multiple current levels. Let's begin by launching the application. From the SES software folder, double-click on the Tools folder. Then click on the SESampacity icon to launch the application. Here we see the main screen of the SESampacity software. From the main screen, click on the Minimum Conductor Size Radio button. One of the new features in SESampacity is a table to specify the fault data. The first column simply indicates the fault stage number. The second column indicates the symmetrical RMS current in kiloamps at its respective stage. The third column indicates the ending instant of the corresponding stage. Please keep in mind that the beginning instant of a stage is equal to the ending instant of the previous stage. For the first stage, the beginning instant is at 0 seconds. The last column indicates either the x/r ratio at each stage or the decrement factor, depending on the method selected. It is essential to distinguish between the two methods. If the x/r method is selected, SESampacity allows the user to define faults with multiple stages. In contrast, if the decrement factor is selected, SESampacity allows only one stage fault because the IEEE Standard 80 defines the decrement factor for the fault stages beginning at 0 seconds only. So we will be focusing on the x/r method for this tutorial. The frequency text box is used to enter the grid frequency and is only used when the x/r method is selected. The conductor characteristics group determines the physical properties of the material. For this tutorial, we will be choosing copper annealed soft drawn 100% conductivity from the drop-down menu. The text box field in the maximum allowable temperature section is for entering the final temperature that will not damage the conductor at the end of the fault event. This value can be either the fusing temperature of the material or a temperature value specified by the user. At the bottom of the window, there is an environmental factors section containing the ambient temperature text box. The value entered here indicates the temperature of the surroundings, which is also equal to the initial temperature of the conductor. Once we have entered all of our information in the fault data table, we are ready to proceed. To do this, click on the Process button located in the ribbon near the top of the screen. SESampacity will present a summary of the results in the lower left of the screen. To see the detailed results, we simply click on the View Report button. SESampacity will tabulate the input and fault data together with the material parameters. On the bottom of this page, we can see the output of the computations. The overall asymmetrical RMS current and the minimum conductor size are two important results of this analysis. SESampacity now offers the visualization of the fault current. From the main screen, click on View Plots to see the graphs. The first one is the graphical representation of the symmetrical RMS current. A second graph can be viewed by clicking the Fault Current Waveform tab near the top of the window. This graph shows the fault current studied in the time domain. The Windows group near the bottom of the screen is used to zoom in or out on a specific portion of the waveform. For example, if we want to see the fault waveform from 0.7 to 1.1 seconds, we can simply enter these values in the corresponding boxes. Note that the fault event is cleared at 1.05 seconds. The current, therefore, is 0 after that instant. In the Tools group, the Copy to Clipboard button enables the user to copy the plot and paste it into another document. The Reset Zoom button simply returns the plot to its original view. This concludes our introductory video on how to use the SESampacity application to calculate minimum conductor size. If you have any questions, please do not hesitate to contact us. Thanks for watching.